All right, we're going to do a mini refresher on some special right triangles. So this time we're looking at our 30, 60, 90 triangles. So these are the angle measurements. So if we look at all the triangles down here, I can see a 30-degree angle, a 60-degree angle, and a 90-degree angle. So same here and then same there. So this is the type of triangle. So for this one, it is a little different. Our smallest angle is 30 degrees. So I know that directly across from that angle, the side across from it has a measure of some number that we're going to say is x. Once I have that side, my hypotenuse is the side across from my right angle, so this side here, has a length of 2 times whatever that number was. So if this is x, we're going to say 2 times x. If this was 10, this would be 2 times 10, which would be 20, so on and so forth. Then for our last side, it's across from the 60-degree angle, so the one down here. This has a length of whatever our number for x is, and we're multiplying it by the square root of 3. So if I do the same example where this x is 10, this would be 10, this would be 2 times 10, so 20, and then this side length would be 10 times the square root of 3. So it's a lot easier if I have the side given to me that is across from my 30-degree angle. If you look ahead at my other two examples here, I'm not given that side first. So I am missing this side, which would be the easiest to do, but I can still do it given the measurements of the other ones. So my hypotenuse here has a measure of 12. So I know that I can take that 12 and I can set it equal to 2x. When I do that, I want to solve for x, because whatever I get for x would be the measure of the side here that's across from 30 degrees. So I divide both sides by 2. So I get 6 equals x. So that means that this side here has a length of 6. You might not have to set up this equation. If you know that the hypotenuse is always double the shortest side, and if this is 12, well, half of 12 is 6. And let's talk about another example down here. So let's say I have the same triangle, or the same angle measurements for a triangle. Sorry, so this is 30, this is 60, and this is 90. If my hypotenuse is, well, let's just think of a number, 52. Well, I know that if my hypotenuse is 52, half of that would be the side across from 30 degrees. Half of 52 is 26. So I always take my hypotenuse, cut it in half to get the short side. If I'm given the short side, I multiply by 2 to get my hypotenuse. So going back to the one up here, now that I have two sides, I can do the third side. Spoiler, if you remember with the Pythagorean theorem, since this is a right angle, we could do the Pythagorean theorem for the last side, but since we do have a common rule for a 30, 60, 90 triangle, if this side has a length of 6, then the side that is across from my 60 degrees is going to be that 6 times the square root of 3. And I'm done. So I want to finish the bottom one here. If I had 52, half of that was 26. So if my shortest leg is 26, my other leg would be 26 times the square root of 3. For the very last one, I'm given the side length that is across from 60 degrees. So if I look back over here, that would be this one. So x times the square root of 3, and I have 14 times the square root of 3. That tells me that 14 is my x, so I know my shortest side has a length of 14. My longest side has a length of 2 times 14, which ends up being 28. hopefully that helps with the little mini lesson.